Hey everyone, here's our math problem for today. This is about solving a cubic equation. Here's the problem. Find the value of x given x cubed plus x squared equals 12. X is a complex number. You can pause the video and see if you can solve this cubic equation. Now let's solve this problem together. First, let's write this in the standard cubic equation where the right side is equal to 0. The next step is we are going to split this 12 so that we can come up with special factoring identities. We have here cube, we have here squared. If we can split this 12 such that one is expressed in terms of exponent 3 and the other is in terms of exponent 2, then we can apply the difference of two cubes and the difference of two squares. So let's implement that plan. So we write minus 12 as minus 8 minus 4. Then let's rearrange the order of the terms. Now we know that 8 is 2 cubed and 4 is 2 squared. Then notice now that we have here difference of two cubes and we have here difference of two squares. So let's recall those special factoring formula. Here is the difference of two cubes identity. A cubed minus b cubed equals the quantity a minus b times the quantity a squared plus ab plus b squared, where our a here is x and our b here is 2. For this blue part, we are going to use the difference of two squares, and that is given by this identity. A squared minus b squared is equal to the quantity a plus b times the quantity a minus b. Here again, our a is x and our b is 2. Let's re-express now this pink and blue terms in terms of these identities. So for the difference of two cubes, here is now the result. Our a is x, our b is 2, that is this part. Here, our a again is x, our ab is the product of x and 2 or 2x, and our b is 2, so 2 squared becomes 4. Here, a squared becomes x squared. Now for this blue part, that is the difference of two squares, that is equal to this form. So we have the quantity x plus 2 times the quantity x minus 2, where our a is x, our b is 2. We copy the right side. Next, notice that x minus 2 and x minus 2 are common factors. We have here two terms. This is the plus sign. This entire part here is considered as one term. This entire part here also is considered as one term. And these two terms has a common factor, x minus 2 and x minus 2, which we can factor out. So this pink product divided by x minus 2 would result to x squared plus 2x plus 4, because x minus 2 divided by x minus 2 is 1. So what's left is this part here. Now this quantity x plus 2 times the quantity x minus 2 divided by x minus 2, notice that this x minus 2 and x minus 2 also will be cancelled out, and the resulting quotient would be x plus 2. Then 2x and x are like terms, 4 plus 2 are also like terms. So let's simplify this further. 2x plus x becomes 3x, 4 plus 2 is 6. Just copy all the rest. Now from here, we are going to apply the zero product property of multiplication. We have here a product, the quantity x minus 2 times the quantity x squared plus 3x plus 6, and the product is equal to 0. So from the zero product property, each of these factors could be equated to 0. So solving for x now here, we found that x is equal to positive 2. But for the second equation, the roots here are complex numbers. So let's use the quadratic formula. Here's the quadratic formula. Here, our a is 1, our b is 3, our c is 6. So substituting those values to the formula, we have negative b, so negative 3, plus or minus the square root of b squared is 3 squared minus 4 times a is 1 and c is 6 all over 2a, where our a is 1. From here, it's just a matter of arithmetic computation. So 3 squared is 9, 4 times 6 is 24, 2 times 1 is of course 2. But 9 minus 24 is a negative number under the radical sign, which resulted to an imaginary number. So we can write this as the square root of 15 times I, or I times the square root of 15. That is because this negative 15 can be written as negative 1 times 15. and that is under the square root symbol. And the square root of negative 1 is now this I, and the square root of positive 15 is this part. So putting all together the roots that we found, we now have, for the first part, we already know previously that x is equal to 2. And from this latest result, this can be split into two roots. One is negative 3 plus I times the square root of 15 over 2. And the other one is negative 3 minus I times square root of 15 all over 2. This gives us the three roots of this cubic equation, which is consistent with the fundamental theorem of algebra. There are other ways of solving this. We can use synthetic division, or we can use the general formula for solving cubic polynomials. But whatever method you use, you will arrive at the same result. So thank you very much, and we hope to see you again in our next video. Bye for now.